Hello, folks. Here we are, 1.7. This is our last part before the review and before the quiz or the test. This is just a little bit of review. This is about applying the Pythagorean theorem. So it's going to be giving you some kind of like, quote, real life situations. So students will solve problems using the Pythagorean theory. So here's a little bit of review. Since the Pythagorean theorem is true for all right angles, we can use an algebraic equation to describe it. And this is the one we know, a squared plus b squared equals c squared. In the triangle at the right, the hypotenuse has a length of h, and the legs have lengths of a and b. So here we go. We've got hypotenuse h, leg a or b, and leg a or b. The area of the square of the hypotenuse, h, is h times h, or h squared. Remember, when we have something squared, it's just the thing multiplied by itself. The area of the square of the legs are a times a, or a squared, and b times b, or b squared. The side lengths of the legs can be assigned either a or b. This is your choice. So whether we want to call this a and this b, or we want to call this a and this b, it really doesn't matter. Okay, those two are interchangeable. However, this one is not. Hypotenuse is always going to be the longest. It's always going to be opposite our right angle. Since the sum of the two squares must equal the square of the hypotenuse, we can make an equation for this. So it's always true that h squared is going to equal a squared plus b squared. In the past, the hypotenuse was always called side C, so you may encounter the equation like this, or you may see it the other way, a squared plus b squared equals c squared. Doesn't really matter what side you have what on, which the equal sign. It's all the same. And the key to using this correctly is to always identify the legs and the hypotenuse correctly. So we've seen this in some of the questions that we've done. Sometimes we're solving for h, and sometimes we already have h and we're solving for one of the legs. So it's really important always to identify which of the sides is our unknown. Okay, so that review's in the bag. Let's move on to a few questions. Here's our problem number one. So Emily helped her dad build a large table for doing puzzles. She measured the side at 66 centimeters by 112 centimeters. If the hypotenuse is 120 centimeters, is the table a rectangle? Okay. This is an interesting way of asking it. This is basically asking, are these three numbers a Pythagorean triple? So in order for the table to be square-cornered, the Pythagorean theory must be true for the numbers 66, 112, and 120. If the triangle is a right triangle, then the corners are square. So if this is a right triangle right here, then that means that this would also be, and this would also be, and this would also be. Remember, a rectangle needs to have 4 right angles. So it can't look like, this. This would not be a rectangle, even though it has side lengths that are the same there and the same there. Since it doesn't have those right triangles, it's not a rectangle, it's just a parallelogram. So we need to find out, is it true that h squared equals a squared plus b squared? So what's our h in this one is 120, and our a squared, we can put them either way, 66 and 112. And then I need my calculator. So let's find 120 squared is 14,400. 66 squared, 4,356. And 112 squared, 12,544. So if we add these two up, does it equal 14,440? Let's see. Let me move this over so I can see the plus 4, 3, 5, 6. Okay, no. 16,900. So they do not equal. Since the Pythagorean theory is not true, then the table is not rectangular. Okay, so 14,400 does not equal 16,900. Therefore, Emily and her dad haven't done a very good job of making this table. That's okay. They'll try again. Next example, Vesna is building a triangular cabin. She wants to make sure that the corners are 90 degrees so that all the flooring will fit properly. If one side of the cabin is 12 meters long and the hypotenuse is 15 meters long, what should the other side be? So she wants it to have a square corner right here so that the flooring will fit. Even though she has this part right here, which is going to give her some trouble, and this angle right here, and this angle right here, who am I to say? Let's just figure out how long she needs this length to be to make a 90-degree angle here. Because you can tell if she accidentally makes it too long and it would go out here, it's not going to make this side, it's not going to meet this side, and this angle would be too big. So she needs to make sure she makes this the correct length to make this a 90-degree angle. So let's check. Here we go. In order for the triangle to have a 90-degree angle at the corner, the diagonal must be the hypotenuse of the triangle and the 12 one of the legs. So calculate the length of the other leg of the triangle. So I'm going to show you the two ways. So we can use our formula that's shifted to solve for a leg, or we can use our regular formula and just subtract from each side. So this one we have 15, remember, is our hypotenuse, minus 12 squared equals b squared. 15 squared is 225. Let me go. Subtract 144 equals b squared. Let's do 225, subtract 144. That equals 81 b squared. Then we need to take the square root of each of them. The square root of 81 is 9. So we know that 9 equals b. She'll need to make, I'll write that down at the end. So 9 equals b. And I'll show you the other way. We could have gone 12 squared plus b squared. We don't know that equals 15 squared. So 144 plus b squared equals 225. Then to get the b squared by itself, we need to minus 144 from each side. So that kind of zeroes out. We're left with b squared equals 225 minus 144, which we know from over here is 81. Then we do our final step of taking the square root to get rid of this exponent right here. And we're left with b equals 9. So same no matter which way we do it. So the side should be 9 meters in order for the triangular house to be a right triangle. Next example, Casey goes to school across a vacant rectangular lot every day. The lot measures 120 meters by 65 meters. If they cross the lot diagonally, how much less distance will they walk by crossing the lot? So we're asking ourselves, what's the difference between walking all the way here and all the way here versus walking straight across? So how do we find the distance of walking here and here? Oh, here we go. The distance around the outside of the lot is 65 meters plus 120 meters, so 180 meters. Okay, look at it right here. So if you walked that, you would walk 65 meters plus 120 meters, you would walk that way. And the distance across the middle of the lot, we'll need to find the hypotenuse for that. Oh, good. I've made myself a nice diagram there. So h squared equals a squared plus b squared. So doesn't matter which one we do, 65 squared plus 120 squared. I'm going to need my calculator for this. 65 squared is 4,225 plus 120 squared, 14,400. Now let's add those two up, plus 4225, 18,625. Now we need to take the square root of each. So h equals the square root of 18,625. And let's see what that is. 18,625 square root. Oh, I got to press it first. Square root 18,625 equals, hello? Okay, let's try it again. 18,625 square root. There we go. 136.5 meters. So that's 136.5 meters. Okay, is this a Pythagorean triple? This is a good question. This is a bit of a throwback. Pythagorean triples need to be whole numbers. So I would say no, because 136.5 is not a whole number. And how much distance did they save? Well, remember, if they walk just straight down the triangle, the 65 meters plus the 120 meters, they would have walked 185 meters. And we can subtract the distance that they would walk if they cut across a field, so 136.5. Let's do that. 185 minus 136.5 equals 48.5. So Casey saves 48.5 meters each trip. So totally worth it. Let's do the practice sheet 1.7. Thanks, folks.